Hi, good morning, everyone. Wish you a very happy Merry Christmas. So, we have entered to the ninth lecture session of this environmental engineering. First of all, welcome to Just Gate Civil, and we are here for Mission Gate 2021. And we are going through the crash course for this Gate 2021. And myself, Soumyajit Sen, is teaching or discussing with you environmental engineering. Before today, we have already covered for 8 classes where we have covered up to we are going through the domestic water supply engineering process, and up to coagulation and flocculation discussion is done. So today we will discuss about the filtration process, that is the another segment of the treatment. Now before going to that discussion, just a reminder that if you don't have till the Unacademy learning app in your mobile, go to the app store and type Unacademy learning app, install the Unacademy learning app, and go for GATE and EAC, as we are actually going for GATE and EAC subscription. So GATE and EAC, you can click for the plus subscription and go for the GATE subscription. And while taking the subscription, don't forget to apply the code SEN10. Today, if you are taking subscription and applying this particular code, this is my code SEN10 ACN10, then you are going to get direct 10% discount on the above mentioned value. Don't forget to apply send 10. Now, great news, rather than we can say the new year gift to all civil engineering students, those who are GATE 2022 aspirants. Civil batch A in English and Hindi, both the language, is going to start on 28th December. Save the date, 28th December, 11:15 a.m. where we are going to get the exposure to the topmost educators of Unacademy. And if you are aspirants for GATE 2022, this is the time to start. Don't be late. It's better to start early. Buckle your seat belt and go for the subscription for this batch. While taking the subscription, don't forget to apply SEN 10. SEN 10. And those who are actually 2021 aspirants thinking for another year of preparation, they can also go for this course, go for the subscription, or else you can tell others, your friends, your juniors, to go for this. Another great news, already done once, the second time, Unacademy Combat is coming in this month, December 29, 6 p.m. Register now. Enroll for free. Unacademy Combat, where the questionnaire will be set by the topmost educators, and you will be provided with the video solutions. To unlock, use the code CRACKGATE, CRACKGAT, CRACKGATE. Rank 1 to 3, 3-month subscription or equivalent Amazon voucher you will get. For first rank 4 to 50, you will receive 500 rupees Amazon voucher. Unacademy Combat, once again 29th of December, 6 p.m. Next combat is there, enroll for free. Register now, and to unlock use the code crackget. Let's enter to our chapter. As we are discussing about the treatment of water, we are now entering to filtration process. So till date what we have discussed, अभी तक हम लोग डिस्कस किए हैं. एक चीज तो आपको याद है कि when we are talking about then when we are talking about the treatment of water, then we are actually concerned about two type of impurities. One is particle, another one is microorganism. Particles are of three type. One is suspended particle, second one is colloidal particle, and third one is dissolved solid. Suspended particle size ranges in between 10 to the power -1 to -3 millimeter in diameter. Colloidal particle size ranges in between 10 to the -3 to -5 millimeter in diameter, whereas dissolved solid size ranges in between 10 to the power -5 to -8 millimeter in diameter. For suspended particle, we have gone through the plain sedimentation process. For colloidal particle, we have gone through the coagulation and flocculation process. Now, the terms of dissolved solid. For dissolved solid, we will be using the filtration process. Filtration process is the process where we are going to remove the dissolved solids. Mainly, the target is the dissolved solids. So, in plain sedimentation, what we have done, we are actually controlling the viscosity and turbulence of water in a particular tank, and particles are getting settled down according to their specific gravity. In plain sedimentation, we are not doing anything or not applying anything from the outside. Whereas for coagulation process, we are applying certain chemicals called as coagulant from outside. Right? So that is the coagulation process. So plain sedimentation was unit operation. Coagulation is unit process. Now coming to the filtration. What is filtration process? Filtration is a process where we are going to pass the water through a porous media. We are going to pass the water through a porous media. And this porous media is called as filter media. And this porous media is called as filter media. So passing the water through a porous media will be called as filter media, where filter media is sand, garnet, anthracite coal, etc. Pass the water through a porous media. So how we are going to remove the particles? Suppose this is your porous media. This is your porous media and a particle having higher diameter than the pore size. When you are passing the water through this porous media, particles which are having diameter than the pore, higher diameter than the pore size will get restricted from the flow. That is the process. And generally this porous media will be called as filter media. Generally sand, garnet, anthracite coal will be used as filter media. As no chemicals are used from outside, no chemical forces are applied. That's why this is an unit operation. That's why this is an unit operation. Now, before going to the details of filtration process, one thing we need to remember कि कभी कभार इतना ऑब्जर्व होता है कि that particles, जो particles हैं which are having lesser diameter is also getting restricted. मतलब particle जिसका size pore size से कम है, ideally जो पास हो जाना चाहिए वो उसका भी रुकावट हो रहा है. Now how? So obviously, the basic mechanism of filtration is not only the only mechanism. उसके सिवाय भी और कुछ होते हैं filtration unit में जिसको हमको देखना है. And the overall thing will come as the mechanism of filtration. The overall thing will come as the mechanism of filtration. The whole mechanism of filtration will be of four type, or in four process the filtration processing will happen. Mechanical process, second one is natural sedimentation, third one is electrolytic action, fourth one is biological action. कोई भी चारों एक साथ भी हो सकते हैं, कोई भी एक हो सकते हैं, कोई भी combination is also possible. First one is mechanical process. Mechanical process is nothing but the common and ideal filtration process, where you are passing the water through a filtered media and the particles which are having higher diameter than the pore size are getting restricted to the filtration process. Mechanical process is the ideal one, where particles are getting restricted from the flow as they are having higher diameter than the pore size. Now, secondly, there are natural sedimentation. Natural sedimentation will be like lot many see sometimes smaller size particle is also getting sedimented. Sedimented means कैसे हो रहा है? मैं पहले बोला हूं it is the passing of water through a porous media. When you are passing the water through the porous media, it will be a laminar flow. Whatever may be the condition, whatever may be the situation, in filtration, always laminar flow exists. So, when you are slowly passing down the water through a porous media, suppose this is the porous media where you are slowly passing down the water, a particle may clear certain pores, but as the water is not having that much of turbulence, sometimes these particles are getting sedimented in the periphery of the filtered media. Periphery of the inner layer of the filtered media. So as the particles are naturally sedimented at the periphery of the inner layer of filtered media, that's why it is called as natural sedimentation. And by this process, sometimes lesser diameter particle, lesser diameter means lesser diameter than the pore size, will also get restricted. Natural sedimentation. Next one is electrolytic action. Sometimes charged particles are present in water. Now, according to the charges, two or more than two smaller size particle will attach with each other and they will form a bigger size particle. According to the charges, if two and more than two smaller size particle attach with each other, then they will form a bigger size particle. That is the electrolytic action. Next one, fourth one is biological action. Try to understand this biological action clearly, because the concept of biological action, ये जो concept है, ये concept सिर्फ filtration के लिए नहीं, भविष्य में आपका वेस्ट वाटर ट्रीटमेंट में बहुत ज्यादा काम में आएगा. तो क्या होते हैं, सोचिए, मैं जस्ट एग्जांपल दे रहा हूं कि सोचिए आप मेरे को बोले कि सर आपको खाने के साथ साथ हर रोज एक लोहे का टुकड़ा खाना है. I will die because my digestive system is not designed to digest iron. You are keep on providing this same thing for generation after generation. My next generation will die, third generation will die, fourth generation will die, but after that there will be a generation where evolution occurs and their digestive system will be designed to grab the iron as their food. Same thing happens with the microorganism. अगर आप माइक्रो ऑर्गेनिज्म को कुछ आपका जो पॉल्यूटेंट है वो खाने के लिए दिया कि भैया खा लीजिए इसको, पहला सिचुएशन में तो नहीं खाएगा, सेकंड जनरेशन भी नहीं खाएगा, थर्ड जनरेशन भी नहीं खाएगा, लेकिन ऐसा एक जनरेशन आएगा जो उस पॉल्यूटेंट को अपने खाना के हिसाब से खा लेता है. दिस इज द कॉन्सेप्ट ऑफ बायोलॉजिकल एक्शन. फिल्ट्रेशन में क्या होते हैं? As the topmost layer of filter media is always submerged in water, as the topmost layer of filter media is always submerged in water, microorganism mass grow after certain point of time. कुछ देर के बाद माइक्रोऑर्गेनिज्म मास का ग्रोथ होता है. When these microorganism mass are getting growth, तो फिल्टर मीडिया में क्या क्या डिपोजिट होते हैं? सेडिमेंटेड जो डिसॉल्व सॉलिड्स होते हैं, और उनमें से बहुत सारे पॉल्यूटेंट भी हैं और बहुत न्यूट्रिएंट भी हैं. तो माइक्रोऑर्गेनिज्म को खाना ऐसे ही मिलता है न्यूट्रिएंट की वजह से, और आफ्टर सर्टेन जेनरेशन वो पॉल्यूटेंट को भी खाने लगते हैं. तो इवेंचुअली इरेस्पेक्टिव ऑफ द साइजेस ऑफ द पॉल्यूटेंट, द पार्टिकल्स और द पॉल्यूटेंट्स आर गेटिंग कंज्यूम्ड by microorganism present in the topmost layer of the filter media. समझ में आया? तो और after certain point of time we will observe a brown colored slimy layer at the top of the filter media. Brown colored slimy layer. This brown colored slimy layer is called as dirty skin layer or smudge deck layer. This brown colored slimy layer is called as dirty skin layer or smudge deck, SCHMUTZDECKE layer. Okay, dirty skin layer or smudge deck layer. Clear? That is the mechanism of filtration: mechanical process, natural sedimentation, electrolytic action, and biological action. The types of filter. Now, before going to the classification of filter, we need to know that the classification of filter is done on the basis of certain things. First of all, based on force applied. Based on force applied. Based on force applied, filter will be of two types: gravity filter and pressure filter. Based on force applied मतलब कैसे पानी बह रहा है. It will be of two types: gravity filter and pressure filter. Gravity filter is when the water is flowing with the control of gravity forces. Where the flow of water is controlled by gravity forces. And pressure filter is the flow of water is controlled by certain mechanical devices like pumps. So gravity filter is the flow of water is controlled by gravity forces, and the pressure filter is the flow of water is controlled by certain mechanical devices like pumps. That is gravity filter and pressure filter. This is the classification of filter on the basis of force applied to the flow. On the basis of force applied to the flow. Now, based on the number of filter media used, कितना फिल्टर मीडिया यूज हो सकता है उसके ऊपर बेस करते हुए द फिल्टर विल बी ऑफ थ्री टाइप. Single media filter, where only sand and used as filter media. Dual media filter, where sand and anthracite coal are used as filter media. Multimedia filter, where sand, anthracite coal and garnet is used as filter media. So based on the number of filter media used, filter will be of three type. तीन तरीके के होते हैं. नंबर वन सिंगल मीडिया फिल्टर जहां पे सिर्फ सैंड यूज होते हैं एज फिल्टर मीडिया. डुअल मीडिया फिल्टर जहां पे सैंड और एंथ्रासाइट कोल will be used as filter media. Anthracite coal is the best quality coal available. Peat, lignite, bituminous and anthracite. Four types of coal generally available. Multimedia filter will be the sand, anthracite coal and garnet. Sand, anthracite coal and garnet, three type of things will be used as filter media. Now, third classification is on the basis of ROF. ROF is rate of filtration. The third classification is on the basis of ROF, rate of filtration. What is rate of filtration? It is the volume of water filtered per unit surface area per unit time. It is the volume of water filtered per unit surface area per unit time, where ROF is equals to volume plus surface by surface area into time, where ROF is equals to volume by surface area into time. The volume of water filtered per unit surface area per unit time is ROF definition. तो भैया ये डेफिनेशन इसी तरीके का डेफिनेशन आपने पहले भी देख चुके हैं 2 दिन पहले जब प्लेन सेडिमेंटेशन टैंक हम लोग पढ़ रहे थे. प्लेन सेडिमेंटेशन में ऐसा ही उसका डेफिनेशन था. किसका? एसओआर का, सरफेस ओवरफ्लो रेट. एसओआर का डेफिनेशन ऐसा ही था, where volume of water sediment or water treated per unit surface area per unit time was the SOR. So SOR की वजह से हम लोग क्या कर रहे थे? एरिया ऑफ सेडिमेंट सरफेस एरिया ऑफ सेडिमेंटेशन टैंक हम लोग निकाल रहे थे. हाउ? बाय Q बाय SOR. सेम थिंग इज हियर. ROF का डेफिनेशन है ये जो इक्विवेलेंट टू SOR है. यूनिट वगैरह सब कुछ है आपका SOR की तरह. SOR से क्या कर रहे थे हम लोग? SOR से सेडिमेंटेशन टैंक का सरफेस एरिया निकाल रहे थे. इधर रेट ऑफ फिल्ट्रेशन से हम लोग क्या करेंगे? टोटल एरिया ऑफ फिल्ट्रेशन निकालेंगे. टोटल एरिया ऑफ फिल्ट्रेशन that will be equals to Q by ROF. Total area of filtration will be equals to Q by ROF. That we are going to find out. The same thing, nothing changes there. Same thing, same SOR type of parameter, ROF here. Now based on ROF, filter will be of two types, slow filter and rapid filter. It's quite obvious that slow filter means the ROF will be lesser and rapid filter means the ROF will be higher. Now that is the classification of filter. Now here in your screen two type of things written, two filter written. One is slow sand filter, another one is rapid sand filter. We need to discuss in details these two type of filter used in the process. One is slow sand filter, another one is rapid sand filter. First we will discuss about slow sand filter, their components, their design parameters, schematic diagram, etc. Then we will go for rapid sand filter and the same thing for rapid sand filter. Okay. So now we are going for the discussion of slow sand filter. Before going to the schematic diagram or design components, let's discuss about certain prelude of slow sand filter. From the term itself, उसका नाम को देखते हुए आपको क्या क्या लग रहा है? पहला तो है कि सिंगल मीडिया, क्योंकि सिर्फ सैंड यूज हो रहा है. सिंगल मीडिया ग्रेविटी टाइप स्लो फिल्टर इट इज. It is single media gravity type slow filter. Rate of filtration is very less. rate of filtration is very less, but RF will be equals to 100 to 200 liter per hour meter square. Rate of filtration is very less, but ROF will be in between 100 to 200 liter per hour meter square. As it is a slow process, anything is slow will be very much efficient. Anything is slow will be very much efficient. Like in the gate paper also, if they are providing you ample amount of time to solve the gate questions, suppose they are telling that okay, don't have to solve in 3 hours, go for solving the question for 1 month. You will see your efficiency will get increased quite obviously. Lot many students will get 100 out of 100. So for slow sand filter, efficiency is the highest when compared to other type. For slow sand filter, efficiency will be the highest when compared to other type. It is so much efficient that pre-treatment is not required. Pre-treatment is not required and post-treatment is optional. It is so much efficient that pre-treatment is not required and post-treatment is optional. And sometimes it can remove the microorganism also from the system. So what is pre-treatment? Pre-treatment is nothing but coagulation flocculation. It is not required if you are going for slow sand filter. So it will not only remove the dissolved solids, but also it will remove the this colloidal particles. Post treatment, which is the disinfection process. Pre means previous, post means baad mein, later on. Disinfection process is also optional. Sometimes it can remove the microorganism from the system. Not only slow sand filter, rapid sand filter also do the same thing, but microorganism removal efficiency for slow sand filter will be much higher than other types. Now we are going for slow sand filter. Now we are going for slow sand filter. Now, components of slow sand filter. Now when we are concerned about the components of slow sand filter, let me first discuss about, then we will go for the schematic. First of all, there is one filter box. Filter box is open rectangular type box constructed with concrete or masonry, where size ranges in between 1000 to 2000 meter square, where depth will be in between 2.5 to 3.5 meter, and slope will be in between 1 in 100. So that is filter box. That is a schematic. This one is the filter box. This one is the filter box, which is holding everything. This is the inlet. This is outlet. Then filter media. We have already seen that only sand will be used as the filter media. So sand is used as filter media, where thickness of sand bed will vary in between 90 to 110 centimeter. The thickness of sand bed will vary in between 90 to 110 centimeter. Filter media, 90 to 110 centimeter sand bed. Other specification will be like D10. D10, you know, it's called as effective diameter. Effective diameter, that means 10% of the sand particles are having diameter less than that. That is called as D10. Effective diameter will vary in between 0.2 to 0.35 millimeter. Effective diameter will vary in between 0.2 to 0.35 millimeter. Uniformity coefficient Cu, which is nothing but the ratio of D60 to D10. D60 to D10, it will vary in between 1.8 to 3. 1.8 to 3. Okay. Cu, uniformity coefficient. D60 means again the same type of definition, where 60% of the particles having diameter less than that. Then it is coming to gravel bed. What is gravel bed? So to hold the sand bed, gravel bed is used, and the thickness of gravel bed will be in between 60 to 90 centimeter. The hold the sand bed, gravel bed is used, and the thickness of gravel bed will be between 60 to 90 centimeter. So what we have observed till now is there is a sand bed of 90 to 110 centimeter thickness. This is sand bed. And to hold the sand bed, there will be a gravel bed of 60 to 90 centimeter thickness. There is the sand particles. Now, gravel bed is also a porous media, but bigger size. Gravel bed is bigger size gravels, stones. So, what is the job of this gravel bed? To hold the sand bed. Now, you can tell that when it is passing through the gravel bed, then also water is passing through a porous media. Now, the point is gravel bed will not take part in filtration process. Why? Gravel bed will not take part in filtration process. Why? Because the pore size of sand bed, pore size of sand bed is much less than the pore size of sand bed is much less than the gravel bed. So when if a particle is able to pass, if a particle is able to pass to the pore size of sand bed, then the pore size of gravel bed will not be able to restrict it. The particle is able to pass the pore size of sand bed, then gravel bed pore size will not be able to restrict it. That's why gravel bed will not take part in the filtration process. It is used only to hold the filter media or sand bed. Hold the filter media or sand bed. This is what written here. Due to the higher pore size of gravel bed from the sand bed, particles which are escaped from sand bed will not get restricted by the gravel bed. The purpose of gravel bed will be to hold the sand bed as sand particles should not get escaped with the flow of water. Sand particle should not get escaped with the flow of water. And gravel bed will not take part in filtration process. Gravel bed will not take part in any kind of filtration process. This is only to use, only to hold the sand bed. So till now whatever components we have seen, first of all we have seen the filter box, then we have gone for what? Then we have gone for the filter media, sand bed, then we have gone for the gravel bed. Okay. Then fourth is under drainage system. Under drainage system. So water will come at the top of sand bed as is the gravity type filter. So from top to bottom it will flow, and this water will flow through sand bed, then will come to gravel bed and will be collected in under drainage system. What is under drainage system? It is the system, or it is the structure, or it is the arrangement. We can say it is an arrangement. एक तरीका है जिस तरीके से collection and dispose of treated water will be there. Collection and dispose मतलब collection की कैसे होता है पानी का, और उसको dispose करना, dispose to the outlet कैसे करते हैं देखना पड़ेगा. Under drainage system consists of two type of drains. Here don't confuse yourself. The drain means it will carry the dirty water. No, it's actually a pipeline, or it's actually an arrangement to flow the water. Under drainage system consists of two types of drains. One is lateral drain, another one is central drain. One is lateral drain, another one is central drain. ड्रेनेज सिस्टम ऐसे होते हैं जो दिखाया गया है. लेट्स सी. जैसे ये अगर ग्रेवल बेड है, इसके ऊपर है सैंड बेड, water is coming through this. Now below the gravel bed there will be a vertical drain called as lateral drain, where the treated water will be received. 1, 2, 3, like lot many lateral drains will be there. These vertical drains are called as lateral drains, where treated water will be received, and this lateral drain will discharge the water to a horizontal drain. This lateral drain will discharge the water to a horizontal drain, which will receive the treated water from the lateral drain and discharge it to the outlet. This lateral drain will discharge the water to a horizontal drain. This horizontal drain will receive the water from the lateral drain and discharge it to the outlet. The two types of drain will be there in this arrangement. One is lateral drain, which is vertical to x-axis. Another one is central drain. So there may be lot many lateral drains present, but central drain will be only one. So there may be lot many lateral drain present in the system, but central drain will be only one. The lateral drain will collect the water from the bottom of gravel bed and it will discharge to central drain. Lateral drain will collect the water from the bottom of gravel bed and it will discharge to central drain. Central drain will collect the water from lateral drain and it will discharge to the outlet. And there will be lot many lateral drain, but central drain is only one. Understand this? The lateral drain will collect the water from the bottom of gravel bed and it will discharge. ये किसको देगा? ये देगा central drain को. इससे काम खत्म. Central drain ये collect करते हुए सारे पानी को लेके outlet पे फेंकेगा. तो बहुत सारे lateral drain हो सकते हैं below the gravel bed, but central drain will be only one. Okay. Now, fifth one is other components which will be used in the slow sand filter will be inlet, outlet, different valves will be obviously there, and there will be a head loss measuring devices. Generally, piezometer is used to measure the head loss. between inlet water and outlet water. Head loss measuring device, inlet, outlet, different valves, and head loss measuring device will be there in the other component segment. So there is this basic, very basic schematic of a slow sand filter. Very basic schematic of slow sand filter from inlet. From inlet, water will be there. It will pass through the sand bed, then it is coming to gravel bed. From the gravel bed, it will come to the lateral drain, central drain. It will go to outlet. This is the piezometer, which is the head loss measuring device. Assume this is a piezometer. It doesn't look like a piezometer. Pardon me. Assume it's a piezometer. So this is inlet, this is outlet, this is the head loss measuring device, this is under drainage system, this is filter box, this is sand bed, gravel bed, this is the water level, everything is there. Now try to understand the operational process. Initial head loss. Initial head loss is 10 centimeter. ऑपरेशन चालू होने के टाइम पे नॉर्मली इनिशियली जो हेड लॉस रहेंगे दैट विल बी 10 सेंटीमीटर. Now, as time increases, it is written here, head loss increases. How? सोचिए, this is your sand particles. जितना टाइम बढ़ेगा, जितना टाइम जाएगा, जितना टाइम बीतेगा, lot many particles are getting deposited in the pores. Eventually, the passage of water through these pores of sand particle will get restricted as time increases. Written here, there will be more and more deposition of particles. More and more deposition of particles will tell that passage to flow of water will decrease. It will decrease the passage to flow of water. So as inlet will get water at a particular rate, but the water going to the outlet, that particular rate is getting decreases. So if inlet head is this and water going to the outlet is decreases, eventually when time increases, head loss increases. When time increases, head loss increases. तो ऐसा ही चलता जाएगा. टाइम बढ़ रहा है, हेड लॉस बढ़ रहा है, ऐसा ही चलता जाएगा. आंसर इज नो. मतलब हेड लॉस जितना बढ़ रहा है उतना मतलब है कि आपका जो पोर्स हैं वहां पे पार्टिकल डिपोजिशन बढ़ रहा है. So there will be a particular head loss. There will be a particular head loss which will indicate. There will be a particular head loss which will indicate that the filter media is exhausted and cleaning is required. There will be a particular head loss. एक particular head loss value आप क्यों measure कर रहे हो? Head loss बढ़ेगा. Fair enough. क्यों measure कर रहे हो? That is an indicator mechanism is there. What is that indication? कि एक particular head loss value को कहते हैं terminal head loss value, अंतिम head loss. उस वैल्यू जब रीच करेगा उसका मतलब है कि भैया आपका जो दिस फिल्टर मीडिया है दैट इज एग्जॉस्टेड, वो खत्म हो चुके हैं, अब उसका क्लीनिंग जरूरी है. When that head loss is reached, it's called as terminal head loss value, that is 70 to 90 centimeter. The value of terminal head loss is 70 to 90 centimeter. So initial head loss is 10 centimeter and terminal head loss is 70 to 90 centimeter. So when the filter media is reaching this terminal head loss value, that indicates that your filtering process will have to be stopped right now, because the cleaning of filter media is required. Because the cleaning of filter media is required. Cleaning of slow sand filter is done by scratching or scraping process. The cleaning of slow sand filter is done by scratching or scraping process. स्क्रैचिंग और स्क्रैपिंग है क्या? आप देखेंगे कि नॉर्मली अगर खाना पकाने के टाइम पे कुछ मटेरियल बर्तन के नीचे स्टिक हो जाता है, लग जाते हैं, तो क्या करते हैं हमारे मम्मी लोग जो काम किचन में नॉर्मली काम करते हैं, तो दे आर एक्चुअली टेकिंग अ स्पून, पुटिंग सम वाटर एंड स्क्रैचिंग इट. द सेम थिंग, इट्स नथिंग बट द रिमूवल ऑफ top 3 to 5 centimeter, removal of top 3 to 5 सेंटीमीटर ऑफ सैंड पार्टिकल, क्योंकि सबसे ज्यादा डिपोजिशन ऑफ पार्टिकल होते हैं टॉप लेयर ऑफ फिल्टर मीडिया में. रिमूवल ऑफ टॉप 3 to 5 centimeter of sand particle, it is done once in 1 to 3 months. It is done once in 1 to 3 months, where scratching is allowed up to 50% of its initial thickness. Where scratching is allowed up to the 50% of its initial thickness. इसका मतलब क्या है? तो आप ऊपर से 3 से 5 सेंटीमीटर ऑफ सैंड पार्टिकल हटा रहे हैं 1 से 3 महीने में, तो सोचिए आप 100 से चालू किए हैं. पहले बार स्क्रैचिंग किया 97 हुआ और 95 को 5 सेंटीमीटर हटा दिया. सेकंड बार कर लिया तो 90 हुआ, थर्ड बार कर लिया तो 85 हुआ. चल जाएगा कब तक? इसके बाद करेंगे तो 80 होगा, उसके बाद हो जाएगा तो थिकनेस घटते 75 होगा, 70 होगा. तो ऐसे कितना देर तक चलेगा ये? चलेगा कब तक? अलाउड अप टू 50% ऑफ इट्स इनिशियल थिकनेस. मतलब अगर आप 100 से चालू कर रहे हैं तो 50 तक ही आप जा पाएंगे. 65, 60, 55, 50, इतने बार बैकवर्ड एक स्क्रैचिंग इज पॉसिबल. 1 2 3 4 5 6 7 8 9 10. After that, you have to take the filter media, throw the filter media away. You replace the filter media with the newer one. So scratching and scraping process defines the removal of top 3 to 5 centimeter of sand particle. Removal of top 3 to 5 centimeter of sand particle. It is done once in 1 to 3 months. It is done once in 1 to 3 months. But scratching is allowed up to 50% of its initial thickness. Scratching is allowed up to 50% of its initial thickness. From 100 it is start. If it is started with 100, you can reach up to 50. If you are starting from 110, you can go up to 55. If you are starting from 90, you need to go up to 45 only. Clear? Now, total area of filtration, it's evident. We have already discussed. It will be Q by ROF. Total area of filtration will be Q by ROF. And number of filter media used will be equals to total area of filtration by area of one filter. So total area of filtration will be Q by ROF, where number of filter media required will be equals to total area of filtration by area of one filter. Total area of filtration by area of one filter will be the number of filter required. Okay, this is the basic. Let's recap the thing. slow and filtered, single media gravity type slow filtered, ROF is less, varying between 100 to 200 liter per hour per meter square. Efficiency is highest when compared to other type. Pre-treatment is not required. Post-treatment is optional. Components: filter box, filter media, gravel bed. Gravel bed does not infiltration process. Under drainage system. Other component: lateral drain, central drain, initial head loss, terminal head loss, cleaning process, and design parameters. Now, going for rapid sand filter. We are going for rapid sand filtration process. Well, so like the slow sand filter, here we are comparing with rapid sand filter, where rapid sand filter is the single media gravity type rapid filter. It is the single media gravity type rapid filter, where rate of filtration will be in between 3000 to 5000 liter per hour per meter square. Rate of the previously for slow sand filter, the rate of filtration will be in between what 1000 to 2000 100 to 200 liter per hour per meter square. It is 3000 to 5000 liter per hour per meter square. Here I should write the efficiency will be in between 95 to 98%. Efficiency will vary in between 80 to 85%. And pre-treatment and post-treatment both are mandatory. That means whatever they are in the slow sand filter, that pre-treatment is not required and post-treatment is actually optional. Here both are mandatory. Now once again going to the rapids and filter components, like the same one. First of all, there will be filter box. Then that is open rectangular type box constructed with concrete. Same thing, size, depth and slope is defined. Size of the box will be 10 to 80 meter square. Depth will be 2.5 to 3.5 meter and slope is 1 in 100. Same thing is defined. Then coming to filter media, where sand is used as filter media. Where thickness of sand bed will be 60 to 90 centimeter. Previously, the thickness of sand bed was 90 to 110 centimeter. You need to always compare between what is happening in rapid sand filter and slow sand filter. Then only you can understand the thing. Slow sand filter is much more easier to think. For rapid sand filter, you need to visualize lot many things. We'll come to that. D10, obviously there was some values of D10 and CU here also 0.35 to 0.55 mm. CU as D62 by D10 were 1.2 to 1.8. CU gravel bed, previously also it was the thickness of gravel bed is 60 to 90 centimeter. Here also 60 to 90 centimeter. Rest same as slow sand filter. Why? Because in rapid sand filter also gravel bed will not take part, because the point is the process is fixed. Gravel bed will not take part in any kind of filtration thing. It will be used to hold the sand bed. Okay. Finally, under drainage system will be same as slow sand filter. Under drainage system will be same as slow sand filter. Under drainage system will be same as slow sand filter. Clear? Now, the other component segments, there will be inlet valve, outlet valve, air pump. Inlet and outlet valves are there in the slow sand filter also. Head loss measuring device is also there, but two things are new here. One is air pump and wash water trough. Air pump is the pump which will blow air. That is okay, we can understand, but where it is used we will discuss. And wash water trough is nothing but a passage. Trough is nothing but a passage to flow water. Why it is called as wash water trough, that will also we will discuss after discussing the schematics of rapid sand filter. Schematics of rapid sand filter, we will use this. Now, that is the schematics of rapid sand filter. Try to understand the schematics very clearly. Try to understand the schematics very clearly. Their inlet is there, inlet valve is there, a sand bed, gravel bed, sand bed, gravel bed. Normally, this is the under drainage system, and there these structures are the wash water trough. There are two tanks. One tank is filtered water storage tank. Another tank is wash water storage tank. There is another tank which is start dot two, which is denoted as the backwash water storage tank. Everything I will explain. Star one is the air pump, and I have drawn the 6 valves A, B, C, D, E, F. 6 valves are there. Now, why this operation? We will not go to directly to the formula, because this operation is required. If you see the gate questions, if you don't understand the operation, then solving those questions will be much sometimes very tougher. If you understand the question from the statement itself, you will easily solve those questions. That's why you need to understand the operation clearly. You need to understand the operation clearly. So the A is called as inlet valve. A is called as inlet valve. B is called as filtered water valve. E is called as filtered water valve. This one. C is called as this one, wash water valve. C is called as wash water valve. D is called as maturation valve. We discuss everything. Don't need to worry. Maturation valve. E is called as backwash water valve. E is called as backwash water valve. And F, this is called as air valve. Air valve. The 6 type of valves we have. Now, generally, initial head loss will be 10 to 20 centimeter. Initial head loss will be 10 to 20 centimeter. initial head loss will be 10 to 20 centimeter, and like previously the terminal head loss was how much? 70 to 90 centimeter. Here it is 2 to 3 meter. Now for slow sand filter we are only banking on the head loss value to get understand whether the this a filter is exhausted or not. But here we are not banking only on the head loss value. We will keep on measuring the outlet turbidity, outlet water turbidity or filtered water turbidity. Okay, filtered water turbidity. Now there are 2 points. So previously we are only banking on the head loss value. The turbidity breakthrough, there will be a value which will be called as turbidity breakthrough value. एक value है जिसका value है 2.5 to 3 NTU. मतलब दो चीज आप लगातार मेजर करोगे, एक है आपका इनलेट और आउटलेट वाटर के साथ हेड लॉस, और दूसरा आप मेजर करोगे टर्बिडिटी वैल्यू ऑफ द फिल्टर्ड वाटर. हेड लॉस वैल्यू जैसे पिछले बार था कि सिर्फ आप हेड लॉस मेजर कर रहे हो. हेड लॉस वैल्यू अगर 2 to 3 मीटर के अंदर रहेगा दैट इज टर्मिनल हेड लॉस वैल्यू, एंड टर्बिडिटी का वैल्यू है टर्बिडिटी ब्रेक थ्रू वैल्यू 2.5 to 3 NT. व्हिचएवर रीचेस अर्ली, सोचिए कि टर्मिनल आपका हेड लॉस वैल्यू है 1 मीटर लेकिन टर्बिडिटी का वैल्यू है 3 NTU. You need to stop the operation, clean the filter. मतलब हेड लॉस अगर टर्मिनल हेड लॉस पे ना भी रीच करें लेकिन टर्बिडिटी अगर टर्बिडिटी ब्रेक थ्रू पे रीच कर जाए, वी हैव टू स्टॉप द ऑपरेशन, क्लीन द फिल्टर. वाइस वर्सा, अगर आपका हेड लॉस वैल्यू है 2 मीटर लेकिन टर्बिडिटी वैल्यू है 1.5 NTU, that means turbidity has not reached its breakthrough value, then also you need to stop the operation, clean the filter. Always you have to stop the operation, clean the filter, whichever reaches early. Two parameters are there: terminal head loss and turbidity breakthrough. Terminal head loss and turbidity breakthrough value, whichever reaches early, you need to stop the operation, clean the filter. To stop the operation and clean the filter. Now previously cleaning of slow sand filter is done by cleaning of slow sand filter is done by scratching or scraping process, but here the cleaning of rapid sand filter is done by backwashing process. The cleaning of rapid sand filter is done by backwashing process. What is backwashing process? Backwashing process का कॉन्सेप्ट ऐसा है, आप देखोगे कि कभी कभार आपके बाथरूम या कहीं पे भी घर पे कहीं पे गंदगी या मैल फैला हुआ है. What will generally do? We'll take a mug of water or a bucket of water and throw in higher velocity towards that dirt. What will be assumed that when the water is flowing at the higher velocity, it will take away the dirt particle along with it. Same concept will be used in backwashing also. Certain portion or amount of filtered water will be thrown to the filter bed. कहाँ से? Opposite to the direction of filtration. तो अगर आपका देखिए इधर, look at here, so this is your filter bed. Filtration is happening from top to bottom side. So certain portion of filtered water, कौन सा पानी लोगे आप? filtered water ही लोगे. throw करोगे किधर से? back side of the filter bed, from opposite to the direction of filtration process. That is called as backwashing method. Certain portion of filtered water will be thrown to the filter bed opposite to the direction of filtration, is called as backwashing, and filter is getting from backside, that's why it is called as backwashing. Is that clear? So क्या है backwashing? Certain portion of filtered water, when you are taking certain portion of filtered water and throwing that filtered water opposite to the direction of filtration to the filter bed, is called as backwashing. As the filter is getting washed or cleaned from the back side, that's why it is called as backwashing process. That's why it is called as backwashing process. That's why it is called as backwashing process. Now, generally, backwashing is done once in 1 to 2 days, and backwashing is done for 10 to 30 minutes. You should remember that during backwashing or during any cleaning process of any filtration, your filtration process will be stopped. Otherwise, cleaning is not possible. तो अगर सोच लीजिए कि 24 घंटा आपका दिन है और उनमें से आधा घंटा आपका बैकवॉशिंग में जा रहा है, तो आपका ड्यूरेशन ऑफ फिल्ट्रेशन होगा 23.5 hours and duration of backwashing will be 0.5 hours or 30 minutes. Is that clear? And generally 2 to 5% of the filtered water will be used for backwashing. Generally 2 to 5% of the filtered water will be used for backwashing. Generally 2 to 5% of the filtered water will be used for backwashing. Now, इन बैकवॉशिंग जब कर रहे हैं आप, मैंने पहले ही बोला कि पानी को लेके एक हायर वेलोसिटी में आप एक्चुअली थ्रो कर रहे हो टुवर्ड्स द फिल्टर मीडिया. तो जैसे सोचिए आप छोटे 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 सैंड पार्टिकल हैं और जिसके वो पानी को लेके आप थ्रो कर रहे हो, देन व्हाट विल हैपन, द सैंड पार्टिकल्स विल गेट अपार्ट, दूर हट जाएगा, एक दूसरे से दूर चला जाएगा. दैट्स व्हाई नॉट ओनली सैंड पार्टिकल, आप दो तीन बड़े चीज भी लेके अगर आप टेस्ट करोगे घर पे, जैसे आप पानी फेंकोगे बहुत ज्यादा फोर्स में, दे विल गेट अपार्ट, their distance will get increased, distance between them will get increased. So during backwashing what will happen, expansion will be there. That's why backwashing is also called as expansion process. Backwashing is also called as expansion process. And anything suffix e will be denoting the backwashing process, that is universal. There's a head loss during filtration is HL. HL suffix e is head loss during backwashing. Okay. जैसे आपका depth of filter media during filtration is Z. Z suffix e is the depth of filter media after backwashing. Like this. Anything suffix e, N is the porosity of sand particle during filtration. N suffix e is the porosity of sand particle during backwashing. Anything suffix e is actually denoting the backwashing process and this is universal. इसको लेके आपको सोचना ही नहीं है. अगर क्वेश्चन में कभी भी suffix e देके कोई पैरामीटर दिया गया है, then and you are not, you need to take it as backwashing. If they are not mentioning also, it is for backwashing. Now, I have to explain the operational process of this filter media. कैसे होते हैं ऑपरेशनल प्रोसेस. अगर आप ऑपरेशनल प्रोसेस ना समझें तो आप रैपिड सेल फिल्टर नहीं समझेंगे. क्या है, कब कौन सा, इतना सारे तामझाम का क्या ही कहानी है, और कब कौन सा वाल्व को बंद करना है, कब कौन सा वाल्व को ओपन करना है, इट हैज टू बी देयर. लेट्स चेक in this operational process. Lot many valves are there. I have told you the name of the valves: inlet valve, filtered water valve, wash water valve, maturation valve, backwash water valve, air valve. बहुत सारे valve के बारे में हम बोल चुके हैं. Let's see what is happening actually. A, तो सिचुएशन समझिए. मैं एक सिचुएशन आपको बता रहा हूं जहां पे या तो आपका आउटलेट का पानी का टर्बिडिटी ब्रेक थ्रू पे रीच किया है, मतलब पहले सिचुएशन में सब कुछ बंद है, नॉर्मली इनलेट खुला हुआ है, ए खुला हुआ है और बी खुला हुआ है, पानी आ रहा है, फिल्टर हो रहा है, पानी जाके फिल्टर वाटर स्टोरेज टैंक में आ रहा है, तो ऑब्वियसली ए इज ओपन एंड बी इज ओपन, बाकी सब कुछ बंद है, फिल्ट्रेशन हो रहा है. फिल्ट्रेशन होते होते आप क्या कर रहे हो, मेजर कर रहे हो, क्या मेजर कर रहे हो, आउटलेट वाटर में हेड लॉस मेजर कर रहे हो. हेड लॉस मेजरिंग डिवाइस इज नॉट हियर एक्चुअली shown, it is there. It's not possible to show everything in a schematic two dimension schematic figure. So head loss you are measuring as well as you are measuring the turbidity. Now suddenly you have seen that any one of them, yeah, either turbidity breakthrough part or the head loss has reached its terminal value. What you need to do? You have to stop the operation. You have to clean the filter. Now, what is the process of stopping the? जैसे ही आपको ये देखने को मिलेगा, देन क्या करेंगे आप? पहला काम होगा आपको ए को बंद करना, क्लोज ए, क्योंकि आप इनलेट में पानी और नहीं चाह रहे हो. क्लोज ए. ओके, फर्स्ट थिंग विल बी क्लोज ए. First thing we have seen it is written as close A. Now what we will do? अब A को तो बंद कर दिया, ऑलरेडी पानी है सिस्टम में, ऑलरेडी पानी है सिस्टम में, तो अलाउ द वाटर टू कम अप टू द एजेस ऑफ द वॉश वाटर ट्रफ. मतलब पहले इतना तक सोचे पानी था, ए और बी खुला था, बाकी सब कुछ बंद था. अभी पहले ही आप ए को बंद कर दिए हैं, और नाउ व्हाट यू आर डूइंग, यू आर अलाउइंग द वाटर टू कम अप टू द एजेस of wash water trough. This wash water trough is actually a passage. Now it is closed, but there is some work to do. So अभी तक सिर्फ मतलब ए जब बंद हुआ तब क्या खुला है? सिर्फ बी खुला हुआ है. तो इनलेट का फिल्ट्रेशन चल रहा है, चलते चलते जब तक ये पानी वॉश वाटर ट्रफ का एज तक आ जाएगा, then what you will do, you will close the B. You will close B. अभी क्या हो रहा है? सिर्फ ए और बी खुला था, पानी आ रहा था, फिल्ट्रेशन हो रहा था. पहले ही आप जब टर्बिडिटी ब्रेक थ्रू या टर्मिनल हेड लॉस पे रीच किया, पहले ही आपने क्या किया? आपने ए को बंद कर दिया और पानी को आपने वॉश वाटर ट्रफ का एज तक आने का मौका दिया. Then what we will do? We will close B. तो अब ए बी सी डी ई एफ सब कुछ बंद है. फिल्ट्रेशन इज इन स्टेबिलाइज्ड स्टैग्नेंट कंडीशन. क्या करना है? आपका ऑपरेशन बंद हो चुका है. करना क्या है आपको? साफ करना है. साफ करने का तरीका क्या है? पहले देखिए, जो एयर पंप है तो ग्रेवल बेड के साथ लगा हुआ है. क्यों? जनरली बहुत बार ऐसे देखे होंगे आप कि नॉर्मली अगर आपके कोई धूल, हाथ में कोई धूल मैल है या नॉर्मल डस्ट इज देयर, व्हाट जनरली यू विल डू, यू विल डू लाइक दिस, or you will blow some air from your mouth to remove the dust particles. If anybody is having or sometimes you may have seen many persons having this bad habit of getting tobacco, खैनी लेने का, हाथ में ऐसे करते हुए फिर they are blowing here to remove the dust particles from that thing. So this air pump, this first job is to open this F, air valve. F is air valve. Open F and operate the air pump for 2 to 3 minutes. क्या करेगा ये? जो dart particle blow, that it will blow air to the gravel bed. It will blow air to the gravel bed, pores to sand bed. तो जो डार्ट पार्टिकल जो स्टिकी है, स्टिक करके गए हैं पोर्स में, उसको लूज कर देगा. इट विल लूजन द स्टिक डार्ट पार्टिकल्स और लूजन ऑल द डार्ट पार्टिकल्स. मतलब डार्ट पार्टिकल को हटाना अभी इजी हो जाएगा. समझ में आया? 2 से 3 मिनट के बाद आपका एयर पंप का कहानी खत्म. क्लोज एफ. आफ्टर 2 to 3 minutes the job of air pump will be over. Now what we will do, we will close the F, air valve. Once again, your system is stagnant. तो कहानी हो गया है. अब क्या करोगे? Now open E. See, after closing the air valve, you are opening what? Opening E. And this is the tank which is backwash water storage tank. मतलब एक portion of filter water is already stored in that particular tank. जैसे आप E को ओपन करोगे, water will be thrown through this. पहले पानी कैसे आ रहा था? Sand bed, gravel bed, lateral drain, central drain, and going to this filtered water storage tank outlet. Now what will happen? Open E, you are flowing, allowing the water stored in the backwash water storage tank will flow from central drain, lateral drain, gravel bed, sand bed. Same situation in the opposite direction. Same situation in the opposite direction. So already darts are loosened and backwash is done in a higher rate of filtration. It will take the water and जैसे ही यहाँ पे water पानी आएगा, पानी का लेवल बढ़ जाएगा और जैसे ही पानी का लेवल बढ़ जाएगा, पहले कितना तक था आप देखे होंगे, बाल्टी का लेवल तक अगर पानी है उसके वो थोड़ा सा भी पानी दिया तो ओवरफ्लो हो जाता है। वैसे ही वॉश वाटर ट्रफ का एज तक पानी है, थोड़ा सा ही पानी बढ़ जाता है तो वाटर विल कम टू दैट वॉश वाटर ट्रफ बाय ओवरफ्लोइंग इट, and this wash water trough is actually connected with this valve C to wash water storage tank. You will open the C. So open E, water is flowing through the central drain, lateral drain, gravel bed, sand bed, increasing the level of water. Water is overflowing through wash water trough. Opening the C, water, the backwash water, the dart water, because that water is already taking the particles along with it, will come down to this wash water storage tank. Is that clear? Open E and pump the already stored water for backwashing. Open C. Okay, after some time close E and then close C. So after some time close E and close C. So जब backwashing हो जाएगा, आप पहले E को बंद करेंगे, उसके कुछ देर बाद आप C को बंद कर देंगे। भैया सिस्टम में क्या हुआ अभी फिर से? A, B, C, D, E, F सब बंद। A का काम, B का काम, C का काम, E का काम, F का काम हम देख चुके हैं, D अभी तक हम लोग नहीं देखे हैं, लेकिन वो भी देखेंगे। तो पहले बार जब सब बंद हो गया था, पहले बार जब आपको स्टेबलाइज कंडीशन में आ गया था, स्टैग्नेंट कंडीशन में आ गया था फिल्टर, तो आपको क्या करना था? आपको क्लीन करना था। आपको क्या करना था? आपको क्लीन करना था। और अभी जब स्टैग्नेंट पोजीशन में आया है, आपको क्या करना है? आपको फिल्टर करना है, क्योंकि क्लीनिंग हो चुका है। व्हाट यू विल डू? यू विल फिल्टर द वाटर। फिल्टर द वाटर। फिल्टर करने के लिए पहला क्या चाहिए? पहला आपको ए को ओपन करना है। ओपन है। क्यों ए को ओपन करना है? क्योंकि वो ए ही है जो इनलेट पानी देगा। नाउ इमीडिएटली आफ्टर बैकवॉशिंग क्या होते हैं? इमीडिएटली आफ्टर बैकवॉशिंग का bed will be expanded. Expanded matlab the pore size will get expanded immediately after backwashing. So immediately after backwashing, if you take the filter water, that will not be of that good quality. Immediately after backwashing, the filtered water will not be of good quality, क्योंकि जब उस टाइम पे सोचिए ये था ओरिजिनल फिल्टर मीडिया, आफ्टर बैकवॉशिंग इट इज हैपेंड। सो ओरिजिनल फिल्टर मीडिया का जो पोर साइज है, बैकवॉशिंग के बाद पोर साइज बढ़ रहा है, तो जो पार्टिकल ओरिजिनली रिस्ट्रिक्ट होने वाले थे वो अभी पास हो जाएगा। इमीडिएटली आफ्टर बैकवॉशिंग द फिल्टर्ड वाटर will not be of good quality. So initially after backwashing, as the filtered water is not of good quality due to the expansion of filter media, then first 10 to 30 minutes of the filtered water will get bypassed to wash water storage tank. पहले 10 से आधा 30 मिनट का जो टाइम है इनिशियली आफ्टर बैकवॉशिंग, जो पानी बी तक आने वाले थे उस बी अभी भी बंद है। एक खोलने के बाद ये पानी को बाईपास किया जा रहा है। दिस वाटर इज एज दैट इज नॉट अ गुड क्वालिटी वाटर, यू आर नॉट एक्सेप्टिंग इट इन द फिल्टर्ड वाटर स्टोरेज टैंक, दैट वाटर इज गेटिंग बाईपास्ड टू द वॉश वाटर स्टोरेज टैंक थ्रू डी। यहाँ पे डी का काम है। एंड दैट टाइम is called as maturation period. That time is called as maturation period. After maturation period, when you are confident, okay, now your filter media will produce good quality water, then you will close D, close C, everything will be closed, and then you will open B. So A will be open, B will be open. Your filtration and the accepting of filter water will occur. Is that clear? So first, what you will do, you are closing A, allowing the water to come up to the edges of the wastewater trough. Then you are closing B. Opening EF, operating the air pump for 2 to 3 minutes. Then you are closing F. Then opening E, open the E, and open the C. After that, close E and close C for some time. Then you open A. Filtration is occurring, but as the immediately after backwashing, due to the expansion of filter media, as the filtered water will not be of that good quality, that's why you are not accepting the filtered water. You are bypassing that filtered water by opening D and C to the wastewater storage tank, and you will do it for first 10 to 30 minutes initially after backwashing. This period is called as maturation period, and D is maturation valve. After that, we'll close D and C simultaneously. Then you will open B and accept the filtered water in the filtered water storage tank. That is the operation of rapid sand filter. Hope it is clear to you. Hope it is clear to you. Now, we are going for the design of rapid sand filter. Similar fashion, total area of filtration will be Q by ROF, and number of filter media used will be total area of filtration by area of one filter. Number of filter media used will be total area of filtration by area of one filter. Now, here is an important note that we need to take one unit as standby always, whether it is mentioned or not mentioned in the question. When number of filter is asked, that is only for rapid sand filter. That is only for rapid sand filter concept. Only for rapid sand filter. We need to take one unit as standby always, whether it is mentioned or not in the question. When number of filter media is asked, this is only for rapid sand filter. This standby thing. Again, I am telling you, it will be used only if and only if they are asking to find out the number of filter media. Now, percentage of filtered water used in backwashing will be defined by volume of water used in backwashing by volume of water filtered into 100. Volume of water used in backwashing by volume of water filtered into 100. That is defining percentage of filtered water used in backwashing. And volume of water filtered will be rate of filtration into duration of filtration into area of filter. Percentage of filtered water used in backwashing will be volume of water used in backwashing by volume of water filtered into 100. Where volume of water filtered will be rate of filtration into duration of filtration into area of filter. Rate of filtration will be liter per hour meter square. The duration will be hour will be cancelled and area of filter meter square will be cancelled. The game of unit conversion. Same like volume of water used in backwashing will be rate of backwashing, duration of backwashing and area of filter. Same game. Rate of backwashing, duration of backwashing and area of filter. Same game. Now, head loss during back filtration process. Head loss during the filtration process. During filtration, head loss will be defined as HL is equals to FZV square by GD. FZV square by GD into 1 minus N by N cube. FZV square by GD into 1 minus N by N cube, where N is the porosity of sand particle during filtration process. Where N is the porosity of sand particle during filtration process. Z is the depth of thickness, or depth of means depth nahi, or thickness of sand bed or depth of sand bed during filtration process. You can cut through. Thickness of sand bed during filtration process in meter. Rate of filtration is nothing but actually it is nothing but the ROF, as it is having the essence of velocity. That's why denoted in the velocity term. You know the H2R and ROF. G is the acceleration due to gravity. D is the diameter of sand particle in meter, and F is the friction factor. F is the friction factor, where F is defined by 150 into 1 minus N by RE. 150 into 1 minus N by RE plus 1.75, where F is defined by 150 into 1 minus N by RE plus 1.75, where RE is Reynolds number, हम जानते हैं, which is nothing but inertia force to viscous force, which will be defined by rho Vd by mu. Rho is density of water, V is the filtration velocity, that means the rate of filtration, D is the diameter of sand particle, by mu is coefficient of dynamic viscosity or coefficient of absolute viscosity into phi. Phi is actually called as the shape factor. Phi is actually called as the shape factor. And this equation is called as Kármán and Kozny equation. This equation is called as Kármán and Kozny equation. This equation is called as Kármán and Kozny equation. HL is equals to FZV square by GD into 1 minus N by N cube. Kármán and Kozny equation. Now, head loss during backwashing. Head loss during backwashing. HLE defined by the equation ZD into 1 minus NE into G minus 1. HLE is equals to ZD into 1 minus NE into G minus 1. Where ZD is the thickness of sandbed after backwashing. ZD is the thickness of sandbed after backwashing. NE is the porosity of sandbed after backwashing. JD is the thickness of sandbed after backwashing. NE is the porosity of sandbed after backwashing. And G is the specific gravity of sand particle. G is the specific gravity of sand particle. ZD is thickness of sandbed after backwashing. NE is the porosity of sandbed after backwashing. and g is the specific gravity of sand particle. As I have told you before, that everything will be suffix e is denoting the backwashing process. Now this particular equation will be supported by two more equation. This particular equation will be supported by two more equation. One is ZD by Z is equals to 1 minus N by 1 by N, 1 minus N. ZD by Z is equals to 1 minus N by 1 minus Ne. That is the first equation, important. Second equation is Vb is equals to Vs into Ne to the power 4.5. Vb is equals to Vs into Ne to the power 4.5. Where Vb is ROB, rate of backwashing, and Vs is settling velocity of sand particle. And Vs is settling velocity of sand particle. Vb and Vs here. Now, significance of the second equation. Try to understand it carefully. What is the second equation? Vb is equals to Vs into A to the power 4.5. This is nothing but rate of backwashing Vs is settling velocity of sand particle. From this equation, obviously Ne will be less than 1 porosity, and settling velocity Vs is downward direction velocity, and Vb is the backward velocity, that is upward direction velocity. So Vb, as Ne is less than 1, so Vb will be less than Vs always. So downward velocity will be more than the upward velocity, right? Downward velocity will be always more than the upward velocity. Clear? As the downward velocity is always more than the upward velocity, so resultant velocity will the resultant velocity will act always in the downward direction. What is the significance? What is the significance of this equation? What will happen? Vb will try to take the particle along with it. Vb will try to take the particle along with it, but Vs will take the sand particle to stay in the sand bed. That is the significance of this equation. Vb will try to take the particle away from the sand bed, but Vs, the settling velocity of sand particle, will take the sand particle in the sand bed. Otherwise, your sand bed thickness will get reduced. Vb will try to take the particle away from the system, but Vs, the settling velocity of sand particle, will take down the sand particle in the system. So that is the reason when you are choosing for the rate of backwashing or backwashing velocity, you have to keep in mind that what will be the settling velocity of sand particle, because rate of backwashing should be always less than settling velocity of sand particle. Otherwise, your particle will go away from the system during backwashing. So during backwashing, BB will try to take away the particle and Vs will take it down in the system. That's why your downward velocity, downward resultant velocity is always important than the upward one, because if Vb is more than Vs, what will happen? It will take away all the particles or certain particles along with it. So Vb, when you are choosing Vb, you should keep in mind that the Vb should be always less than Vs, settling velocity of sand particle. Vb should be always less than Vs, settling velocity of sand particle. Okay. Now the relationship between concentration of particle and sand bed depth. The relationship between concentration of particle and sand bed depth. So this is, if this is the sand bed, depth is Z. Initial concentration of particle is taken as C naught. Initial concentration of particle will be taken as C naught, and final concentration will be taken as Ct. The efficiency will be C naught minus Ct by C naught into 100, eternal formula. C naught minus Ct by C naught into 100, or if you take C naught 1 minus Ct by C naught into 100 is the another form. Simple. Or if you take the efficiency in one side, it will be Ct by C naught equals to 100 minus eta by 100. Now, dc by dz, rate of change of particle concentration along with time depth, will directly proportional to Ct. इनिशियली अगर 10 पार्टिकल हैं और आपको 5 मिनट बाद अगर आपको पार्टिकल मिल रहा है 3, तो डीसी डीजेड किसके ऊपर डिपेंड कर रहा है? अगर लेंथ सेम है 1 मीटर के, सोच लीजिए, तो 10 माइनस 3 बाई 1 मीटर, दैट इज 7. नाउ अगर 10 से चालू है, क्योंकि इनिशियल नंबर ऑफ पार्टिकल इज नॉट इन योर हैंड, इट विल बी ऑलवेज फिक्स्ड. तो 10 से चालू है, 1 मीटर बाद आपको मिल रहा है 5, तो डीसी डीजेड इज 5. सो किसके ऊपर डिपेंड कर रहा है? इस z डिस्टेंस कवर करने के बाद कितना पार्टिकल बचा हुआ है उसके ऊपर डिपेंड कर रहा है डीसी डीजेड वैल्यू. So dc dz is equal to minus lambda c. Why? Lambda is proportionality constant, is called as filter constant. Lambda is proportionality constant, is called as filter constant, which is fixed for a filtration process. Which is fixed for a filtration process. So dc dz will be equals to minus lambda c, where lambda is proportionality constant, which is fixed for a filtration process, and dc by c. So dc by c. Why this negative sign is coming? Because increase in the depth of filter will get reduction in particle concentration. Increase in the depth of filter, we will get reduction in particle concentration. Reduction in particle concentration. dc by c will be equals to minus lambda dz. dc by c is equals to minus lambda dz. But if you integrate from C naught to Ct, if you integrate from C naught to Ct, dc by c is equals to minus lambda 0 to z dz. C naught to Ct, dc by c equals to minus lambda 0 to z dz, where ln c from C naught to Ct will be equals to minus lambda 0 to z dz. So ln, if you take this upper limit to lower limit, Ct by C naught is equals to minus lambda z. ln Ct by C naught is equals to minus lambda z. minus lambda is equals to 1 by z ln ct by c naught, or lambda is equals to minus 1 by z ln ct by c naught, or lambda is equals to 1 by z. If I take minus sign with the ln part to the power, it will be c naught by ct, or lambda is equals to 1 by z ln 100 by 100 minus eta. All the forms of lambda filter constant. And this set of equation, this fourth set of equation, which is actually defining the relationship between the concentration of particle with the filter media depth, is called as Iwasaki equation. This fourth set of equation, which is actually defining the concentration of particle with the depth of filter, is called as Iwasaki equation. Is called as Iwasaki equation. Clear? Now, going for certain operational problems of rapid sand filter. We are going for certain operational problems of rapid sand filter. First of all, the mud ball formation. Sometimes, due to the presence of mud particles in water, a bigger size ball will form due to the stickiness, which enters to the sand pores and try to push them apart. Is called as mud ball formation. And when the mud ball is pushing the filter media apart, then some cracking will be there, which is called as cracking of filter bed. And during the loosening of darts before backwashing, sometimes air get entrapped between the sand particle, which is called as air binding. And due to the raw water quality, sometimes material loses its strength. Material means sand bed, sand particle. Is called as sand particle incrustation. Briefly, I have discussed about the certain operational problem of rapid sand filter: mud ball operation, cracking of filter, incrustation of sand particle, and air binding. These are the major. Now, pressure filter. Pressure filter is also a rapid sand filter where raw water will flow under a pressure head of 30 to 70 meter. Generally, ROF will be in between 6,000 to 15,000 liter per hour meter square. Efficiency of pressure filter will vary in between 60 to 70%. D10 will vary 0.5 to 0.7 mm. CU will be 1.2. Generally, it is used in some commercial places like swimming pool, hospitals, private places, etc. Dual media filter. Anthracite coal and sand both are used as filter media. First, there will be 50% will be the anthracite coal and 50% will be the sand. Anthracite coal G will vary in between 1.4 to 1.5 and D10 will be 0.9 to 1.1 mm. So coarser to finer particle. Coarser to finer particle. Anthracite coal will be coarser but lighter. Sand particle will be finer but heavier. Advantage is ROF will be very high from 10,000 to 15,000 liter per hour per meter square. Efficiency will be around 90%. Obviously, it's costly to maintain and backwashing is difficult as lighter material is at the top. And it can happen that during backwashing, the backwash water is taking the coal particle along with it. Multimedia filter, I have already told you, in multimedia filter, anthracite coal, sand, and garnet will be used as filter media. Once again, it's coarser to finer. 60% will be the anthracite coal. G and D10 value is written here. 30% will be the sand particle and garnet will be 10%. G and D10 value is provided. Again, efficiency will be almost equal to the dual media filter. Rate of filtration will vary in between 15,000 to 20,000 liter per hour per meter square. In terms of rate of filtration, that multimedia filter will be equals to or greater than dual media filter, will be more than rapid send filter, will be more than slow send filter. Efficiency for slow send filter will be greater than rapid send filter, greater than equals to dual media filter, greater than equals to multimedia filter. Okay, that's there. In brief, what we have discussed, first of all, we have discussed about the filtration, what is filtration, then we have gone for the mechanism of filtration, then we have gone for the types of filter on the basis of different parameters, then we have gone for the slow sand filter, prelude, its components, its operation, design parameters, schematic diagram, cleaning process, rapid sand filter, components, schematic, very important, different types of valve, operational parameters, backwashing, operational procedure, design parameters, head loss during backwashing, and head loss during filtration. First, Karman and Kozny equation, head loss during backwashing, mode equation supporting the head loss during backwashing, the significance of the second equation, relationship between the concentration of particle and sand bed depth, Iverson equation, operational problems of rapid sand filter, pressure filter, dual media filter, and multimedia filter. So, just a reminder, first of all, that if you don't have this Unacademy learning app in your system, go to the Play Store and type Unacademy learning app, install it, go to this GATE and EAC module, go for plus courses where you are going to get personal mentorship, you will going to get the best educators in Unacademy platform, get the subscription, and during taking the subscription, don't forget to apply SEN 10. If you apply it today, going to get 10% of the discount in the above mentioned values directly. SEN 10, don't forget my code is SEN 10, ACN 10, SEN 10. And a great news, good news, New Year bonanza to all of our civil engineering friends. Starting Evolve for GATE 2022 Civil Batch A English and Hindi starts on 28th December 11:15 a.m. SEN 10, and when you're going for this subscription also, don't forget to apply the code SEN 10. Another good news, 29th of December, Unacademy is launching next combat. In this combat session, the paper or questionnaire will be set by the topmost educators. Video solution will be provided for each and every question. Register now and to unlock, use code CRACKGAT, CRACKGAT. December 29, 6 p.m. Save the date. Enroll for free. Win exciting prizes. If you are getting rank 1 to 3, you're going to get 3-month subscription or equivalent Amazon voucher. Or rank 4 to 50, 500 rupees Amazon voucher to each. So we have covered today the filtration process. We have completed the filtration process. So we have covered all the particle segment in the domestic water supply part. Next, we will go for the disinfection process, where we will deal with the microorganism. Thank you for this session. See you tomorrow. Goodbye.